Hi, today we're going to talk about the fourth type of transformation. It's called a dilation. And if you've ever gone to the eye doctor, you might have had them dilate your pupils so they can get a good look inside. And in that sense, they were enlarging your pupils. But you could also dilate also means to shrink, to make smaller. So it's to make larger or smaller. And it is in a certain way. So when you make it larger or smaller, all the angles stay exactly the same. So the shape appears the same. So if you had a right triangle, you'd still have a right triangle. If you had an isosceles triangle, you'd still have an isosceles triangle. And then over here it says with respect to the center. I'll point it out as we get there. So there's a few vocabulary words: dilation, obviously, center of dilation, and then the most important one really is scale factor. Factor means multiply. And so when we scale it, we're going to be told, let's multiply and increase the size by doubling or tripling. Or we might be saying we're going to decrease the size by taking half the size. So the scale factor is what we need to actually create the dilation. So they're pretty easy to recognize. So here's a dilation over here. The red figure was made smaller. It became the blue. And here's where they're showing you the center of dilation. I can draw a line from corresponding vertices. So this vertex and this vertex are in the same location in the triangle. And if I draw a line backwards from all the corresponding vertices, they meet at a center point. When we do them, the center point is going to be the origin. And obviously on the right, the figure did not stay the same, change size. It's still congruent. So this is just a translation. So this is a translation, and this one is the dilation. Now, what these two transformations have in common is they keep the orientation. So this vertical line in the smaller blue triangle is on the left, and it's also on the left in the larger red one. Same thing with the translation. The horizontal line is on the bottom of the blue and on the bottom of the red. So they keep the orientations, but you will never confuse a dilation with a translation because of the size change. All right, so here's an on your own to do. Pause the video, work on that. Okay. So now we're going to actually do the transformations. And it's pretty straightforward. Here it says draw the image of triangle ABC after a dilation with a scale factor of 3. And then identify the type. Here we mean, was it enlarged or reduced? So that's what we mean by the type of dilation. Okay, so I'm going to show you, basically you're just going to take each X and Y coordinate, so both parts of the point, and multiply it by whatever factor they tell you. So I just went offline and I show you here that I multiply the X and the Y to get my new coordinates. And now I'm going to go over and graph the two figures over here on the coordinate plane. So over here, I've drawn ABC, which is the smaller triangle that we started with, the pre-image, and here is our image. And you can see the orientation didn't change. The right angle at B is in the upper right, the right angle is at B prime, upper right. And that's what you would expect. Now, what type is this? Well, clearly our new figure, our image is larger, so this was an enlargement. And now, of course, we're going to go take, let me look at this over here. We can check by drawing a line from the origin through each vertex. So this is unique to when we do it on the coordinate plane. It will go from the origin. So what they're saying is I could draw a line from the origin through the A's, from the origin through the B's, and the all will meet back here because that's the center, and that's your ultimate check. You also will notice that the side length have changed by the scale factor. So the original AB was 1, the new AB is 3. The original BC is 2 units in length, the new B prime C prime is 6 units in length. And so the next one we're going to do is multiply by 1/2. So hopefully you have a sense that multiplying by a scale factor less than 1 is going to have a different effect. Just like multiplying by a number less than 1 has a different effect. So I'm just going to take all these coordinates and multiply by 1/2. So as you go over here, it's a lot of steps. With a number like 1/2, it's almost easier to do it in your head. You can see the focus here. I was writing the wrong number. So just make sure you're multiplying 4 times 1/2 is 2. 4 times half times -6 is -3. And it's pretty straightforward, but we had to do a lot of calculations. There are 8 of them, so it's a lot of focus. Right? And then the same thing, we're going to go draw this on the coordinate grid, each shape. And we see we have our new shape. And if I drew those lines in again, you would see from the origin, there's a line that goes through y and y prime. From the origin, there's a line that goes through x and x prime. Whoops, w and w prime. And obviously the black figure is the new image, and we have reduced it. It's a reduction. Good luck.